Whether you're a beginner or a seasoned developer, C++ is full of hidden traps that catch everyone off guard. Today, we're counting down the top 10 most common C++ mistakes, the kind that cost developers time, sanity, and sometimes even bring down production systems. Number 7 might surprise you, and number 10, it's widely known yet still often overlooked. Number 1 is forgetting to initialize a variable or class filled of primitive types and other types that don't have a constructor. In that case, the variable will contain garbage values, leftover data from whatever was previously stored in that memory location. When having a struct or a class, we can either provide default values to the fields or implement a default constructor that initializes every field. Number 2 is forgetting to delete dynamic memory. Every call to operator new must have a corresponding call to operator delete. If you forget, you end up with memory leaks. However, this advice is more relevant to legacy C++. In modern C++, there's a better way. Modern C++ offers smart pointers like unique pointer and shared pointer, which automatically manage memory and provide clear ownership semantics, so we use them instead. Number 3 is unintentional copy when passing a parameter. When passing parameters by value, C++ creates a copy of the argument. For class and struct types, this can be unnecessary and inefficient, especially if you're not modifying the value. Number 4 is calling std_move where you shouldn't. Using std_move when returning a local variable by value or when passing a temporary object by value to a function prevents copy elision, or in simple terms, compiler optimizations. You can check my full video for wrong usage of std_move, which I will link in the description. Number 5 is storing or returning a pointer to a local variable. That one is a serious mistake and especially common among beginners. When a local variable goes out of scope, the memory it occupied becomes invalid. Any pointer to it becomes dangling, and using it leads to undefined behavior. Number 6 is storing a pointer to an element in a vector of by-value elements. That is not safe because std vector is a dynamic array. It resizes automatically as elements are added. When it resizes, the underlying memory is reallocated, which invalidates all existing pointers and references to its elements. If you need to safely store pointers to elements, one approach is to store smart pointers in the vector instead. For example, you can use unique pointer, but that is still dangerous because there is no way to check if the raw pointer is still valid. A better way is to use shared pointer and keep a weak pointer to the desired element. That way, when you need to use it, you can check if the object is still alive. Number 7 is not marking your move constructors as no-except. If you don't explicitly mark your move constructors as no-except, STL containers like std vector may choose to copy instead of move during operations like resizing. The key idea is that a move constructor typically just steals pointers. It doesn't allocate memory and it shouldn't throw exceptions. Mark your move constructors as no-except to benefit from the cheap move operation. Number 8 is reinventing the wheel by ignoring the standard library. This is a very common mistake, especially for beginners. As a general rule, if the standard library already provides it, use it, don't reinvent it. Many developers waste time writing their own sorting functions, binary search, or data structures, when optimized and well-tested versions already exist in the standard library. Number 9 is using print statements instead of a debugger. That might be fine for small school assignments, but in real-world software, where you're dealing with thousands of lines of code, they quickly become unmanageable and confusing. A proper debugger gives you far more power. It's not just for finding bugs, it's also a great way to understand unfamiliar code. You can check my full tutorial on C++ debugging, linked in the description below. And finally, number 10 is forgetting to define a virtual destructor in a polymorphic base class. That is a serious mistake that can lead to memory leaks. If a derived object is deleted through a pointer to the base class, the destructor of the derived class will not be called. To fix this, we need to mark the base destructor as virtual. And don't forget the rule of 5. When providing a user-defined destructor, copy constructor, or copy assignment operator, including defaulted and deleted, you need to add all 5 special member functions. And there you have it, 10 of the most common C++ mistakes that developers still make. If you found this helpful, give it a like, share it, and don't forget to subscribe for more C++ tips and deep dives.